Sup, Bellringer enthusiasts? It's a thrashing Thursday here in science class, and of course, we've got lots of things that we need to do. We're talking about nerves and the brain. We've been working on the brain dissection lab. All of my classes have done that. We have a nervous system lab coming due today, so yeah, let's do today's Bellringer, and then we'll get into class. Da 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 do 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 da 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 do do. All right. Da 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 do do do. Hey now. Da 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 do do. Mr. Kovacs class. It's Mr. Kovacs class. You might learn a ton. It's Mr. Kovacs class.
He's interesting too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. Brains, 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 brains. Look at brain here, nice and bumpy. We like it when brains are bumpy. It means there's a lot of neurons that are connected to other neurons. So the bumpier the brain, the better it is. It's not necessarily the size of the brain that makes you smarter. It's how many bumps you have, right? Like a blue whale's got the biggest brain on Earth, but it's not going to pass the Regents test. You probably will, most of you, right? Brain. So we're going to take a look at like how the brain is divided up into different sections and what those sections do. Brains. I'd be remiss if I didn't mention that brains are usually quite bloody. And that's because brains, when they're alive and working in your cranium, right, they're using like 20% of your daily energy use is for brain only. It's only about 2% of your whole body weight, but it uses up 10 times more energy than it should. I mean, it uses 20%. So just staying alive every day, 1/5 of all of your energy needs are just to keep the brain functioning. That's why there's so much blood in the brain. Brains we dissected, of course, those have been drained of blood. So all that's left is the nervous tissue and the neurons and some of the other tissues, connective tissue that are there. Okay? Brains. The brain is divided into sections, and each section's got a different job to do, although there is some overlap between sections and some things, so it's not an exact science. But let me give you an overview of the different parts of the brain. The brain is pretty much broken into 3 parts. There's the cerebrum, which is the lumpy part on the top. There's the little ball behind it called the cerebellum. And then there's the long brain stem, which then becomes the spinal cord. Okay? And these all have different jobs, but the cerebrum's job is primarily to do processing, thinking work. The cerebellum's job is to help coordinate movements, help your balance organ and your other muscles, and keep you upright and moving through space like a normal person, I guess. And then your brain stem, which connects directly to the spinal cord, is like for the very basic functions, things like sleeping and breathing and all those things that you wouldn't want to think about. It controls that. So let's look at the top part of the brain today, the cerebrum. Cerebrum's got a bunch of lobes, and they're named based on which bone in the skull they're behind. Like the one in the front is called the frontal lobe because it's right behind the frontal bone. Okay. The one on top is called the parietal lobe, temporal, occipital, etc. Yeah, those are the different lobes, and they all have different jobs. The most fascinating for us is probably the frontal lobe, because this is where most of your thinking processing goes on. Most of your ability to do math and your ability to know vocabulary and even to speak, to make language is here, right? And it's just neurons sending neurotransmitter signals to each other that allow you to do that. Right behind that, at the parietal lobe, that's pretty much where you can control movements, right? So if you need to move your body somewhere, your parietal lobe is responsible for that, right? I want to move my hand over here. My brain has to actually tell a whole series of muscles to contract and relax. That's done on my parietal lobe, the pink part in this diagram. The green on the side is called the temporal lobe. And the temporal lobe has to do mostly with auditory processing the sounds that hit you in the eardrum, right? So it's like, remember, your ears don't really hear. Ears capture sound. Your brain hears. And likewise, the final lobe, the one on the back, is called the occipital lobe. That's the one that's interesting enough, processes vision. And in humans, our occipital lobe is quite big because we tend to use vision as our primary sense organ, right? The eyes are in the front of the brain, but they have to send long nerve bundles back to the back of the brain in order to be processed. It's called the occipital lobe, occipital lobe. And so we got frontal lobe, parietal lobe, temporal lobe, occipital lobe. Thinking, moving, hearing, seeing, in a nutshell. Right? When we look at a sheep brain, they've got all the same parts. They're just different proportions, right? Like different proportions. Like the frontal lobe is not quite as big as ours. There's not as much going on. They're less likely to be contemplating the meaning of life, right? But their occipital lobe is a little bit smaller too. They don't rely on eyesight as much as we do, but their temporal lobe is bigger. They're better at hearing the world around them than you are. And their motor cortex here in their parietal lobe is about the same. They're just as good as moving as you and I. That's for sure. All right, so the brain's a fascinating organ. We're going to spend some more time with it as we go. So today in class, your Ed Puzzle lesson's about sheep brains, and then we're going to talk more about brains, and then I'm going to talk again about brains. And then the subject today is brains. You got it?